Hi everyone, this is the lesson for 10.2 on tangent lines, and these notes are yellow. They look like this. Okay, so we have a definition and two theorems to talk about for tangent lines, and then we can look at our examples on the inside. So let's look at our first theorem, and it says that a tangent line, or this is our first definition, sorry. A tangent line is a line that intersects a circle in exactly one point. So for this one, that would be point T, okay? And that point is called the point of tangency, so where the line is tangent. So I know when you think of tangent, you think of like sine, cosine, and tangent, but this is something different. This is talking about this segment. So line L is tangent to the circle because it touches it only in one point. So our first theorem says that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So where the radius touches, that point where the tangent line touches, at that point, it's going to make a right angle with that radius that'll touch there. Obviously, we can draw in more radiuses that will touch the circle going towards the tangent line, or we can extend it and touch that, but they're not going to be perpendicular there. It's only perpendicular where the radius touches that point T. Okay, and that backwards is true as well. So if we have a line that's perpendicular to the radius, then it has to be a tangent line. It will only touch the circle in one point, which is what this is saying in converse. Okay, and our last theorem says that if two segments are tangent to the circle and share a common point, so they intersect in one point outside the circle, then those two segments are congruent. So we end up with these two pieces that are congruent, but that's only true because they're tangent to the circle. They only touch the circle at one point. Okay, so that's it for tangent lines. So let's take a look at our example and see what we can do. So for our first two examples, they say to find the value of x, and then a lot of times they'll say this so they don't like give away what's going on in the problem, but they say that assume any lines that appear tangent are tangent. So that means that we would know that the line that's touching the circle here only touches the circle in one point, and by our first theorem that means that it's going to be perpendicular, and it'll be perpendicular over here as well. Okay, so we want to find the value of x. So now we know we have those two right angles there. They gave us a central angle of 117. So if you take a look at what the two radii, and the tangent lines make, it's actually a kite. But it makes a quadrilateral, and we know that all the angles in a quadrilateral add together to be 360. So we can add them all together and make it equal 360 to get x. So if you subtract all that from 360, you will get that x is equal to 63 degrees. So I did mine like an equation. Okay, so add the like terms, subtract them from both sides, and you get 63. You could have just subtracted all those numbers from 360. Okay, so for number two, same idea. We know that the tangent line is going to make a right angle, but this time instead of having four sides, we only have three sides. So now we have a triangle. So all the angles in a triangle add together to equal 180. So we would do the same thing and subtract from 180. So 33 plus 90 is 123, and 180 minus 123 is equal to 57. So that's what x is. So you can write it as an equation like we did for number one, or just add and then subtract from 180. And that's it for finding angles like that. So let's take a look at the next part. So this says to find the radius of the circle, and they gave us some points. We know that it's tangent because they drew in the right angle. Okay, so if it's a right triangle there, that means that we can use our magic Pythagorean theorem to find the value for x, okay, because then we could say that this side is a, b, and then this whole thing here would be c, all of that together. So that means it's x plus 8. So we can plug that in the Pythagorean theorem. So we would have 12 squared plus x squared equals 8 plus x squared. So on this part, you're going to have to FOIL. So I'm going to show my steps over here so I don't have to, I've run out of room. So remember, if it says 8 plus x squared, that means we have 2 of those, and that's why we FOIL. So 8 times 8 is 64. 8 times x is 8x. Here's another 8x. And then x times x is x squared. You can combine like terms to get 16x in the middle. And that's the equation FOILed. So now we can bring it back over here. So 12 squared is 144 plus x squared equals 64 plus 16x plus x squared. So now we can just solve this like a regular equation, and we completely luck out because if we subtract that x squared from both sides, it's going to cancel out. So we don't have any more quadratic equations. From there we would just have a regular two-step. So I'm going to subtract the 64. So we get that 80 equals 16x. We can divide by 16. So x is equal to 5. And that would be it. So the main idea behind these is using the Pythagorean theorem since it's a right triangle. So why don't you go ahead and pause your video and try example number 4. Okay, so same idea here. I didn't show my steps for the foiling, but it's just like the last one, except instead of 8, it's 6. We FOIL it out, get rid of the x squareds, move all our like terms to one side, and we end up with a fraction because this can't divide evenly. So we get 16 over 3. Okay, so let's try our examples at the bottom. Number 5 is a little bit different. Kind of going backwards from the ones that we just did. So here it says, to determine if the line is tangent. So for the line to be tangent, it would make a right angle. And if this was a right angle, then the Pythagorean theorem would work. Remember, back in chapter 5, we talked about the converse of the Pythagorean theorem, that if a squared plus b squared equals c squared, then it's a right angle. So that's how we can determine if this line here is actually tangent, is by plugging those numbers into the Pythagorean theorem. So 7 squared plus 24 squared equals 25 squared. And if they actually equal on both sides, then the line will be tangent. So if we go ahead and square our numbers, this is 576 equals 625. We add those together, we get 625. So since both sides are equal to each other, then the line is tangent. So that would be it. So yes, the line is tangent. Okay, so our last two examples use the theorem number 2 for tangent lines, that if a line is tangent, then it's congruent to the other line if they meet in a point outside. So if that part is 8, this part's going to be 8 as well. If this part's 10, this part's going to be 10 as well. We've got 15, so this side is 15. So they asked us to find the perimeter of the triangle ABC. So that means we would just have to add all this up. So since we have 2 of each one, I'm going to write out like 2 times 8 plus 2 times 10 plus 2 times 15 instead of writing all 6 numbers. So 16 plus 20 plus 30 ends up being 66 centimeters. So the perimeter would be 66 centimeters. Okay, so if you think you got the hang of that, go ahead and pause and try example 7. I'm going to work through it together, though, right now. So the same idea here applies. This piece is congruent to that piece. This one would be this one. And then the last 2 are equal. The issue with this one is they're asking us to go backwards. They say to find, I didn't put the letters on there, but it says to find this length if the whole perimeter is 88. So I'm just going to put a variable there, So we have something to work with, and write an equation. So we have 2x's, 2 15ths, and 2 17ths, and we know it all has to equal 88. So 2x's, 2 15ths, and 2 17ths equals 88. 2 times 15, 2 times 17. So we can just solve our equation like a normal one. So 2x is equal to 24, so that means that x is 12. And that would be it. Okay, so make sure you write down any questions you have, and we'll talk about them in class. Werner out.